Each PV module has different characteristics, electric characteristic. We see here in this case that this PV module has 260 watt peak power. What this watt peak power means is that this PV module can produce at standard testing conditions. This means with 1000 watt per square meter and 25 degrees Celsius at a maximum voltage, it will produce 260 watt. This doesn't mean that the PV module will always produce 260 watts. In some moments the PV module will produce less power whenever there is less irradiation or the temperature is higher. What we also see here is in this sticker the electric characteristic of the PV module. This gives us an overview on how the PV module will behave, and what we will see is that we always have the 260 watt peak, or depending on the power, we have the value which is called max power. Max power is the maximum power that will produce the PV module. We have another value which is the voltage, and in the voltage we have the VMP, which stands for maximum power voltage. This is the voltage which the PV module will produce whenever it's working at maximum power. We also have the maximum power current, which is usually named with IMP, maximum power current. This is given on amperes, and this means the maximum amount of current that the PV module will produce whenever it's working at its maximum power operation point. As we mentioned, these 3 points, the maximum power, maximum voltage in maximum power, and current in maximum power, they all are based on this maximum power point. This means that they should all be on the same, they should be in a voltage and a current so that it gives you the power. However, the PV module will be able to operate on a different voltage and in a different current. This is important to understand, that the PV module does not always need to operate on those values. These values are only important to understand the maximum power point. We have another really important value, which is called the short circuit current. This short circuit current, it's based whenever the PV module is operating at 0 volts, and this happens whenever the PV module is in short circuit. This means whenever we connect, for example, the positive and the negative of a PV module, then we will have a short circuit in the PV module, and this will cause that the current will be the highest that the PV module can produce. We have also another value which is called the open circuit voltage. The open circuit voltage occurs whenever there is no connection on the PV module. For example, if we disconnect the different terminals of this PV module and we measure the positive and the negative of this PV module without any load, we will be measuring the voltage in an open circuit. And this means that this is the highest voltage that the PV module will be able to produce. These two values are really important for us to understand whenever we are going to connect electrical equipment. The open circuit voltage, it's important because we never want to exceed the input voltage which goes into one system. So the voltage that we will use whenever we are going to do our estimations will be the open circuit voltage. Whenever we want to decide which kind of cable or which kind of disconnect switch we are going to use, we need to use the short circuit current, which is the highest current that will be occurring whenever there is one short circuit. So basically these are the most important parameters which our PV module will have. We will also see that there is some curve which explains how these parameters look, and this is based also on the irradiation and the temperature. We finally have the last value, which is the maximum voltage that the PV module can support. In this case, and most of the PV modules nowadays can work up to 1000 volts. However, nowadays there are some systems that can operate up to 1500 volts.